Hey, 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 are you ready to do some math where there is no calculators involved? No adding, subtracting, multiply, dividing. Is that even possible? Yes, math is more than just operations and adding and all of that. It's also looking for patterns and finding relationships with different things. So, we are going to talk about questions. Math is about asking questions. We are going to recognize today what statistical questions are. So, we're just going to be analyzing questions. It's going to be more like a language arts day, kind of. So we are going to talk a lot this chapter on the word variability. So let's talk about that first. Variability means having a lot of different outcomes, having many different options. So variability, if something varies, then it has variability. For example, let's talk for a moment about the weather in Utah in the springtime, right about now, right? If we look at our forecast, we're going to see sunshine, clouds, rain, snow, more sunshine, right? Our temperature sometimes, often, goes random. Okay, there is a lot of variability in our weather in Utah in the spring. Whereas if you were to go to Hawaii, there's not much variability ever. It's like a solid 80 degrees every single day of the entire year. So there's not a lot of variability in Hawaii. There is a lot of variability in the weather in Utah. So that's an example of what variability is and what it's not. And we're going to be talking today about answers that have a lot of variability, that vary, where the answers can change a lot. Okay, so another example of variability is me asking you, hey, how many bricks did you guys all eat today? Zero, right? I could ask each of you, you'd all say zero. There's no variability. But if I ask how many people are in each class at Lincoln Elementary, that would be a lot of variability, right? Even in sixth grade, our three different classes, there is some variability of how many students are in each class. So there's another example of what variability is. So I'm going to have you look at these two questions right here. The first question is, how much does Chester the cheetah weigh on Monday? The second question is, how much do the cheetahs weigh at the zoo? How are these questions different? Well, one thing you might have noticed is with Chester the cheetah, there's only one right answer, correct? He has one weight on Monday. That's how much he weighs. Okay. Whereas the question, how much do the cheetahs weigh at the zoo? The answers will vary, right? Depending on if it's a baby cheetah or a daddy cheetah, there's going to be a lot of variability in your answers. So you'll say that this data or this answer has variability. So I said the word data in there, and you might be like, well, what is she talking about? You might hear data, you might hear data. They're both the same things. Basically, what data is a set of information, a set of numbers, or a set of stuff, a set of info that you've collected about people or things or places, and you have the data, right? I have all of your names. That is data. I have all of your scores. That is data. I have all of your addresses. All of that is data. It's information that I've collected about my students. So, what do we do with data in math? Well, we collect it, we present it, we analyze, we look at it, we try to find patterns, we try to predict things, we try to explain why things have happened with data. This is the field of statistics. So if these next chapters, you're like, oh, this is really fun. I didn't realize I like math, but I like this type of math. Then you want to take some classes, you want to take some statistics classes in high school because this is still math, even though we're not going to use a calculator this whole chapter. So statistical questions have variability. That means that the question that you ask is about a set of data. You got to look at a big group of information in order to answer that question. And the questions might vary, the answers may vary. Okay, so going back, not going back yet, let's look at this question. So statistical questions can ask about a set of data. Okay, you have to look at a collection of data in order to answer a statistical question. So if I were to say, what is the height of the tallest person in my class? Can I just figure out the answer, or do I have to collect some data first? I have to collect some data, right? I have to measure all of my students or at least line them up, and then I can see who is the tallest person in my class. That is what makes it statistical. Okay, so now going back to our cheetah question, kind of, if I'm just moving all over the place, aren't I? How much does the cheetah weigh today? That just requires me to look at that cheetah right there, right? There's only one answer. So that's not a statistical question. Whereas the question, how much does each cheetah in a group weigh? How am I going to answer that question? Well, I'm going to need to collect all the cheetahs, put them on a scale, write down all of their weights, and then I will know how much each cheetah in the group weighs. And there'll also be some variability, right? So that is why that first question is not a statistical question, because it does not need us to go collect some data. We just grab the cheetah, just one answer, okay? Now, the second one, it does include us collecting data and collecting information from different places. So that is why that is a statistical question. So let's see if after that, just quick explanation if you know the difference between statistical and not a statistical question. How old is the penguin named Royal Pudding? Is that statistical? It is not a statistical question because royal pudding is just one penguin. So there's going to be one answer. Okay, so not statistical. What about this question though? What is the average age of all the penguins in Antarctica? Is that a statistical question? Absolutely. Why? Because we're going to have to collect all the penguins in Antarctica and we're going to have to weigh them, or we're going to have to ask them how old they are. Hey, penguin, how old are you? We're going to have to figure out how old they are, and then we're going to figure out the average of that. So that is very much a statistical question. It requires us to collect data. Okay? All right, so let's do a couple more examples. One of these is a statistical question, one of them is not. The first question is, what was the low temperature in Chicago each day in March? And the second question is, what was the low temperature in Chicago on March 7th? One of them has one answer. One of them has 31 answers that probably vary. Okay, so question A is a statistical question. Why? Because we're going to have a lot of answers. If we want to know each day in March, that's going to be 31 different answers, and they'll all vary depending on the temperature. But what was the temperature on March 7th? That is just one answer. So it's not a statistical question. Okay, let's look at two more. How long did it take you to get to school this morning? And how long did it take you to get to school each morning this week? Again, the question that only has one answer is not the statistical question. How long did it take you to get to school this morning? That's only one answer, right? But how long did it take you to get to school each morning this week? Well, that's 5 answers, and they'll vary depending on how quickly you got to school. So B is the statistical question. All right, so let's practice writing a statistical question. Here is our data. We have recorded the number of pets in the household of 50 sixth graders. What would a statistical question be? Well, it'd be a question that I have to look at all 50 of those sixth graders in order to answer the question. So a statistical question might be, who has the most pets? How will I know that's statistical? Well, because I have to look at all of my 50 students to see who has the most. Another good example is how many pets do the 6th graders have? Again, that will be statistical because the answer will vary. Some kids have 0 pets, some kids have 50 pets, some kids, all the way in between. So that's also statistical because the answer varies. Okay, let me give you an example of what is not a statistical question. Not a statistical question. Okay, and that would be, how many pets does John have? Why is that not statistical? Well, because there's only one answer. All we have to do is say, hey, John, how many pets do you have? Right? That didn't require us to get data from lots of different places. Yes, we have to get data from John, right? But that's only one person, and that answer doesn't vary. It's just John's answer, right? So that is not a statistical question. How many gold medals has Finland won at each of the last 10 Winter Olympics? And how many gold medals did Finland win at the 2008 Winter Olympics? Definitely statistical. Why? Because we're talking about 10 Winter Olympics. So we're going to have to collect the data from all those Winter Olympics and figure out how many they've won, add them all up. Whereas this one, we just have to look at one thing and there's one answer. So it's not statistical. Okay. Wildlife biologist. Do you know that's what Nick is? He's a wildlife biologist. My husband, Nick. A wildlife biologist measured the length of time that 17 grizzly bears hibernated. A statistical question would be, how long do these grizzly bears hibernate, right? Because we're going to have to look at all 17 of them, and it'll probably vary. A not statistical question would be, how long did Humphrey the bear hibernate last winter? We only need to look at Humphrey the bear, right? So not statistical. A doctor recorded the birth weights of 48 babies. A statistical question might be, what was the average of all the babies' weights? Well, you're going to have to collect all of the babies' weights to find the average. So that's statistical. Not a statistical question would be, how much did the first baby born weigh? We only have to look at one baby, right? So not statistical. Give a statistical question that you could ask about the recorded data. So looking at all this, what kind of question could we ask? Well, what rocket is the highest? What roller coaster is the highest? Or what roller coaster is the fastest? Both of those require us to look at all of the information to figure out which one is the fastest and the highest, okay? If we wanted this to be our answer, what could our statistical question be? The question is, or the answer would be 92 miles per hour. So we could ask a question such as, ooh, what is the fastest roller coaster? The Screamer, so 92 miles per hour. Or how fast does the fastest roller coaster go? The answer would be 92 miles per hour, okay? So Rory says that this is a statistical question. He says that the varmint, he's asking how tall is the varmint? Well, there's your answer right there. Did that require us to look at all the other roller coasters to answer that question, or did we just have to look at one thing? We just had to look at the one height for varmint. So that is nonsense. It is not a statistical question because all you had to do was look at one thing. It didn't require us to look at any of the other roller coasters or collect any data. So not a statistical question. Okay, you now know the difference between a statistical question and a not statistical question. Today and in this whole chapter, we're going to be dealing with statistical questions. So there you go. There's the lesson for the day. See you next time.